Yes. The way a vector is written is indicated with two letters with an arrow on top of them. So you know immediately that is a vector. And then you see a specific numbers.
What?
You see 3 up and then down 2 in brackets. What type of Chinese thing is this?
It's ancestry story.
PQ 3 2, that's how you say it, 3 2. The 3 represents the X value. And the the 2 represents the Y value. So, I want you to picture a graph in your mind. Yes, a graph. Yes? And I say I'm moving in the direction 3 2. What does that mean? I'm moving 3 in the X and I'm moving 2 in the Y. That's what it means. I'm moving 1, 2, 3, 1, 2. So the speed or direction I'm going at is 3, 2. You can imagine if I say 1, 1, it's 1, 1. 1, 1. So you can see, as I said in the beginning, the longer the vector, the faster you're going. Theoretically, yes, you're only looking at an arrow. If someone is saying, I'm traveling in the vector 1, 1, you know that's not fast. But if someone says you're traveling in the vector 10, 11, you can imagine he's going pretty fast.
Yeah, pero
Yes.
entre the ads, pero de casa aquí, esta
What do you mean P or Q?
no, it's always on the line, PQ. Oh, no, they graph it, 3, 2.
You draw the line.
From 0 to
It doesn't matter. No, it doesn't matter. Yes, it doesn't matter. So, if we look at A, give the vector of A. What is the vector of A?
3, 2.
3, 2. 3 in the X, 1, 2, 3, X, and then 2 in the Y. All right. The vector of B,
6, 3. Also 6, 4.
6, 4. 6, 4. Now we see who knows their graphs. C, the vector of C. Correct. -3, -2. Looking as a graph. -3, -2. Yes? So, the relationship between A and C. Wait, easy. I have A and I have C. There is something very similar about them.
B is twice of
No, A and C. A and C. Something very similar.
not the same speed.
One, but that's out of mathematics. Physics, that would make more sense.
That's a theory.
Correct. Correct.
What? Gradient. Same gradient.
Yes and no. Yes and no. Same gradient? Yes and no. Why?
Because one is a negative, one is a positive.
Correct. And if you notice, both of them are what? One is parallel of each other. If we reach back a little bit to chapter 19, this is a linear equation. It's just, it has starting point and an end point. Yes? It's a linear equation. This one is also a linear equation. It's the same linear equation. The difference is this one shows the direction that's going, let's say, the positive side, and this one is going the negative side. Nonetheless, both of them are the same linear equation. So if A was y equals x plus 2, this C could also be y equals x plus 2. When I show it to you in vector, you know the direction it's going. Both of them are the same linear equation, the same. The only difference is in a vector form, you know the direction it's going. Because the line is unending, technically, if we go deeper in mathematics. A line is unending, a linear equation. Yes? Easy peasy. All right. Now, oh, sorry, we forgot about that. B.
Twice of A.
Yes, correct. So, the vector of A was 3, 2. And the vector of B is 6, 4. So what did I do to the vector of A? Sorry, from A going to B? I multiplied the vector, meaning it got longer. Yes, think of it in physics, more or less. You're going at a speed and you're, yeah, I'm going 30, I want to go 60. You doubled your speed. Yes? Vectors, extremely easy.
Yeah, no, porque assim para sair.
Certainly, as we progress, it will become every time easier. Trust me.
Somehow I doubt that.
Write the vectors as column vectors. What is a column vectors? For example, PQ. Let's go back. Oh, here, it's already here. This is a column vector. AB, an arrow on top of it equals AB. Remember, the first one or the top one is the X value and B is the Y value. So, you have exactly 2 minutes and 15 seconds. I will do the first, so you have 2 minutes left. A, B, 1, 2, 3, 4, 1, 2. So, AB, oops. AB, the vector of AB. Yeah, you see, vector. Let's put a nice arrow like this. Boom. Yes, it's an arrow. Equals, what was it? 4, 2. That's it. Done. That's it. That's A, or vector AB. 4, 2. Easy peasy. Yes. It's the way you write it. This is the column vector. So you have the points A, B. Yes, this is this one. For example, B is CD. So the vector of AB, so you write AB like that with an arrow on top. The A equals the X value and B equals the Y value. So the X value is 1, 2, 4, and the Y value is 1, 2. So my column vector is AB, 4 in the X value and 2 in the Y value. Yes? You guys remember, columns are from top to bottom. Do not forget, you're gonna get rows and columns, so do not get confused with the two. Rows and columns, rows and columns.
What is this?
So when it's positive, the arrow here.
No, both arrows go to the same side.
So even though it's negative, it goes to the same.
In this
Those who are finished can move on to exercise 3. Do 1, 2, 3, 4. Sorry, A, B, C, D. If you're done, 3. Now you have to draw it. It doesn't have to be in a graph.
so
A, B, C, D. Yes? Just want to know the direction. All right. Exercise 17A. Gonna do 2 of them, 3. Yes. I'm gonna go straight to C, the vector of EF. The vector of EF. Equals 4, 0. That is the vector of EF. 4 in the X and then 0 in the Y. It doesn't go anywhere. Yes? I'm gonna jump immediately to I, the one at the bottom. QR. The vector of QR, it doesn't go anywhere in the x-axis, but it goes downwards, meaning -2. It goes downwards. Yes? Pretty simple, pretty easy. Vectors. Yes? Moving forward to exercise 3, I'm gonna choose A and, no, I'm gonna choose B and D. B and D. 1 minus 2. B equals 1 minus 2. So this is my paper. Yes, here it is. That's the paper. I'm moving 1 in the x-axis, and I'm moving 2 in the, -2 in the y-axis. So what do you get? This is your vector. This is what it should look like. 1 minus 2. Oh. Yes? 1 minus 2. D. 2 minus 4. Two minus 4. I'm gonna draw it on top of it. Mm-hmm. Look what happened. 2 minus 4. It doesn't have to be on top of it, but I just wanted to show it to you. As you can see, there's another color. Two minus 4. I'm still heading in the same direction. The only difference is Bradley is walking and Thisainali is running. But we're still going in the same direction. Yes? Easy peasy. Wow.
I wish Eloquetas.
It stays like this. Look at this. It stays as easy. As we progress, it stays easy.
Okay, mas mira, letra de equation.
Mm.
Até dos A. Ok, e não era da acaba.
It's easy.
O alfabeto tem mathematics. Para X, menina das coisas, né? X não sabe passado.
Algebra.
Algebra will be in any type of form.
E menina, tinha a inventa algebra e X. Adelante, ele não pode cantar uma coisa.
Who invented it?
Yes.
He's a Frenchman who lived in 18 something. He
Yeah, I don't think his
was
skeleton.
René Descartes was his name.
What was his name?
René Descartes.
I don't think his skeleton is even there. Wait, Ash's name is even in an hour because anyway.
He invented also the graph.
Wah, que bueno que la N con otra sirve. Because can't the genius for this reading the alphabet in math. Math is supposed to number only. Yeah, he just like he just looked at the alphabet and like ooh, how the math
Make it small.
I'm not that good.
All right. So, if I have a vector, which is, for example, 1, 2, and you multiply it with 2,
It's still
it becomes, you write it like this. You multiply vectors, so you write it in front of the vector. And then you multiply the number in front with all the numbers in the brackets. So you get 2, 4. Yes? This is called a scalar vector.
That is easy.
Scalar, yes? You're scaling the vector. You can get it in tests. The vector is scaled, so you know, oh, it has been multiplied.
Yes.
Yes? So, what happens now? They name the vector. So, for example, this is A. This vector, the black line, is A. 1, 2, 3, 1, 2. We know that the vector of A is 3, 2. Yes, thank you.
So 2A.
So, yes, if I were to say, what is 2A? You would have to know, oh, wait, that means 2 multiplied by the vector of 3, 2 means it's 6, 4. That's what you should know. Because they name the vectors.
Okay, alphabet and
They name A. This is A, 3, 2. What is 2A? Oh, it becomes longer.
what is negative A?
Correct. They don't do that specifically, but you would have to do it eventually. A third A. We will get there.
Do you think of a negative A?
So what is negative A? Remember, we are focusing on our analytical abilities. If 2A means 2 multiplied by the vector of A, what does negative A mean?
The negative vector.
Negative 1 times 3.
Correct. Negative 1 multiplied by 3, 2. So, what does it become? Negative 3, negative 2. I changed the direction of the vector. So, A was 3, 2. Yes? Negative A, negative 3, negative 2. The only thing that changed is the direction, but it's still the same length. You're still going at the same speed. you're walking from this classroom to 6.5 is the end, and then you walk back. Yes? All right. Vectors as translations. If I have an item, you do this all the time. If you're writing, if you're moving something,
Here, a negative for 8 basically same thing for a negative.
you multiply with 4 and you multiply with negative 1.
That's what
Yes? So, if I have my phone here and I decide to move it there, the question is, where did I move it? If I'm standing at 0, 0, take up the x-axis, I move it 2 to the right and 1 up. The question is, where is it now? It's at 2, 1. It was at 0, 0, and I move it. So, the moving of an object, the moving is called a translation. Yes? You're going to get those names. Under the translation, especially when we get to chapter 13, they're going to use it a lot. Translation, rotation, and you need vectors in order to get there. Yes? That's why you do 17 before 13. Or else they say, translate this object. And they're like, what is translation? Yes? So translation means you're moving an object from one place to another place. Yes? You are not changing the way it is. So if it's like this, I didn't change it and move it. Yes? That's rotation. We'll get there eventually. So it's like this, I just move it. It stays the same. Yes? No rotation has taken place. Yes? So, looking at vectors as rotations. You're moving S to all the other letters. S is standing there, and it moves to A. How do you do it specifically with an object? You look at the points. You don't need all of them. You only need 2 at the most. Yes, because you can get a very weird shape. You just need 1 or 2. 1 or 2. So, this point, what happens? 1, 1, 2. Yes? So the translation was 2. No, this is wrong. This is 1, 2. 1, 2. Even if it's vice versa, it's still wrong. It's negative. So, what is the translation? 1, 1, 2. 1, 2. Here, 1, 1, 2. So, this shape translated in the vector 1, 2. This happens in tests. They're going to give you a shape, a triangle, and then they say, translate this object in the vector 3, 5. And then you have to draw the shape in that vector. Let's look at B. S going to B. 1, 2, 3, 4. 1, 2, 3. So I translated S in the vector 1, 2, 3, 4, 4, and then 1, 2, 3 in the vector 4, 3. Yes? A onto C. That's a different story. A onto C. And look, it's there, so it's only 1. Yes? 1. And then 1, 2, 3. But it's not positive. I'm going downwards, meaning it's negative. I translate it. Oh, I'm going from A, sorry, S. Sorry, S. S onto C. S onto C. 1, 2, 1. But I'm going downwards, so 2, negative 1. S onto C. S onto C. You take the point, move it, and see where it is. Take the point, 2, 1, negative 1. Yes. No, 2, negative 1. S to C. Now, you have 1 minute less, 35 seconds, to give me the vector from the translation from S to D. Translation of S to D. Luigi will give us the answer. And if you have a different answer than Luigi, you are wrong. Luigi, tell everyone what the answer is. 4? 4 0? 5 0. So everyone who does not have 5 0, your answer is wrong. 5 0. You're moving 5 in the X and you're moving nowhere in the Y. 5 0. That's it. All right. This part you already know from physics, but now we are going to do it a bit differently. Yes. One point specific to the other point specific. So the point of S to the point of A. You cannot go from the point, you cannot go from here to there. It will make no sense. You turn it then. Yes? Good morning. We did not see. I did not see. No, no box here. Now, we do something else. We're going to add and hopefully subtract vectors. Oops. I would like for you to draw a graph from negative 3 to 3, both sides, x and y values. Negative 3 to 3, x and y values. standing at the coordinate of -3, 0, draw a vector AB of 1, 2. Standing at the coordinate -3, 0, draw a vector AB 1, 2. This is what you should have. Yes? All right. Yes? Sorry? -3. You -3 to 1. X value, or at the x coordinate of -3, 0. -3, 0. This is the coordinate. And then you draw the vector 1, 2. There, here. 1, 2. Sorry? What do you mean? No, this is on creation. So, standing at the coordinate -3, 0, you draw a vector 1, 2. Standing at the coordinate of -3, 0, you draw a vector 1, 2. You have a second vector at the coordinates -2, 2, -2, 2. That's the coordinate. You have the vector 2, 1. At the coordinate -2, 2, you have the vector 2, 1. So, if I were to walk in the vector AB and then switch to the vector of CD, what would have been my new vector if I walked in a straight line? What would have been -3?
If you walk in a straight line,
Yes. Sorry? Correct.
So now this one is going to be down.
No, it's going up. If I were to walk in a straight line, what would have been my vector? 1, 2, 3. 1, 2, 3. This would have been my vector. Oh, it's poorly drawn. This. And this is called addition of vectors. You can do that. You can add them together. And how do you add them together? Extremely easy. We know the top value is the x value and the bottom value is the y value. So adding vectors together, 1, 2, add 2, 1. That's what we're doing. Yes? You have two vectors. Some people, instead of walking in a straight line to get to their destination, they move around first. But what if you went directly straight to the point, adding them together? What do you get? 1 plus 1 equals 3. And then 2 plus 1 also equals 3. So your vector, new vector, is the new vector is 3, 3. And the thing that they're gonna ask is, do you remember I said we were standing at the coordinate -3, 0? And then I moved in the vector 3, 3. Where am I standing now? At the coordinate 0, 3. Correct. So you have to be able to look at coordinates and vector in the same, one could say, space. Because I could say, I'm standing at this coordinate under the translation. Yeah, there's the word translation. What is the translation? 3, 3. That's the translation. Where am I standing now? I'm standing at which coordinate? I'm standing at 0, 3. That's where I'm standing now. But how do you know that from the coordinate? How do you know that? You have to change the coordinate into a vector. That's what you have to do. That's how it can go from a coordinate to another coordinate using the translation. So, if they're saying I'm standing at -3, 0, you change -3, 0 in a column vector. You change it in a column vector. So what does it become? -3, 0. And what happens under the translation? The translation is positive. Yes, positive. So you add 3, 3. And what is your final answer? 0, 3. So I was standing here, and now I moved to here, under the translation. 3, 3. Standing at a coordinate, and I moved to another coordinate. Yes? What do you mean? If you do this, no, this is how you will get it in exercises. But this is how you also must write it. So if you're gonna get a question, you have an object. It's not gonna be one object, it's gonna be a few. Same with this. Some cases you get the picture, and some cases you only get the coordinates. You get the coordinates 3, 0, 1, 2, and 1, 5. Under the translation 1, 2. Draw the new shape on your paper. You have to know what you're doing. So In your previous graph, draw this triangle. They're gonna say you have a triangle, ABC, and these are its coordinates. Triangle ABC, they say draw. They start off like that, draw it. So you see it, and afterwards you should be able to translate it without able to draw it. Draw a triangle ABC. Zero, zero, that's A. 0, 3. Oh, sorry, this is here. This is B, and then you have 3, 3. It's here. It's not just red. This is your triangle. There it is. And then I say, move the triangle. We're now drawing it in the examination session. You would not have to draw it. You only have to write it. Triangle ABC. Under the translation, they write T under the translation. -2, -1. Draw where the new triangle is. So how do you go about this? You have to write all the coordinates from top to bottom. So you have 0, 0, 0, 3, and then 3, 3. What is the translation? The translation was -2, 1. T -2, whoops. -2, 1. That's the translation. And what do you have to write? 0, 0 plus -2, 1 equals what? 2 plus -2 is -2. Remember, it's a vector. 0 plus 1 equals 1. So that's A, sorry, it's A, B, C. A moved from the coordinate. Where is it standing now? -2, 1. That's where it's standing now. B, 0, 3 at -2, 1 is standing where? At -2, 4. There is where B is standing now. So with coordinate -2, 4. Where is C standing? 3, 3. Standing at 1, 4. So 1, 4. These are the new coordinates of your triangle. So you do not need to draw it. You can just use this, you know what I mean, in a specific test. You don't even have to draw it first and then to move it. This is more theoretical. So you're going to draw it, and at the drawing part, you place an apostrophe. So for example, A apostrophe, B apostrophe, C apostrophe. So A went to where? -2, 1. Here. Here is A right now. A apostrophe. Where is B? -2, 4. -2, 4. Here. This is B. Where is C? 1, 4. 1, 4. Here is C. There is your new triangle. After the transition, it should be standing like that. Yes? You should have something like this. 3 minus 2 is 1. This is the new translation. So it should look something like this. Yes? I moved it 1, 2, negative, and then what? 1 up. Yes? 1, 2, 1. So I transitioned the object in the vector -2, 1. Wow, I feel like this is too easy.
Let me make sure it stays like that.
It's very easy. It's too easy.
And it should stay like that.
Mathematics is easy. I agree.
Just don't. No.
So, recommendation to practice recommendation. To get acquainted with chapter 17.1 as page 389, exercise 2. Page 392. C 1 70C1, that's a good one. Page 394-5.
Okay.
Recommended exercises to get you acquainted with 17.1. It's everything we just did. Yes? So if we look at A, 5A, what is it? Vector 4, 3, subtract B. So, to give an example,
Subtract -4, -8. And
we have 4, 3, 4, 2. 4, 3 minus -4. Wait, is it 4, 3 or 4, 2? 3, negative 4, 2. All right, so to give an example, what happens here? Here you have 4 minus what? Minus negative 4. Here you have 3 minus 2. So your new vector becomes 8, 1. That's it. There's nothing difficult.
What is this? I feel that feeling when no se quieren count. Because, yes,
Correct.
no se quieren count. I swear. Exactly.
Yes, they ask subtract.